Imagine standing at the edge of our solar system, staring into an abyss so cold, so distant, it feels like time itself slows to a crawl. There, 6 billion kilometers from our sun, drifts a world stripped of its title, yet never its wonder. Pluto, a name whispered through generations, now reborn as a mystery far deeper than we ever dared to dream. This is not just a dwarf planet. This is a story that might redefine everything we thought we knew about life, death, and the edge of cosmic possibility. On August 24, 2006, Pluto was officially removed from the Planetary Club. The decision came swiftly, but the implications rippled across the astronomical community like a supernova of controversy. Why? Because the International Astronomical Union rewrote the very definition of what a planet is. To qualify, a world must orbit the sun, be nearly round, and, most critically, must clear its orbit of other debris. Pluto, surrounded by countless icy companions in the Kuiper belt, failed this last test. But here's the twist. That failure turned out to be Pluto's greatest strength. Pluto is a paradox. Smaller than Earth's moon, yet it harbors features more dramatic than anything we imagined. Its surface temperature averages minus 380 degrees Fahrenheit. Yet despite this chilling reality, new evidence suggests this frozen world might be anything but lifeless. Pluto, it turns out, has been hiding secrets. Secrets that have only begun to unravel since the arrival of a mechanical traveler from Earth. On July 14, 2015, after a 9-year voyage covering over 3 billion miles, NASA's New Horizons spacecraft made humanity's first close encounter with Pluto. For a brief moment, it soared past the icy world at 52,000 kilometers per h, capturing data that would take years to decode. What it revealed stunned scientists. Mountains taller than Everest, glaciers of nitrogen, a heart-shaped basin with a pulse of possibility. It was as if Pluto was waiting patiently to show us who it really is. But Pluto is not alone. Its largest moon, Charon, is so massive relative to Pluto that some astronomers consider them a binary system, a gravitational duet in the void. Imagine a silent waltz, two worlds locked in perpetual motion, orbiting a shared point in space. Charon may be just half Pluto's size, but their gravitational intimacy hints at a past collision, or perhaps a cosmic kiss and capture. Together, they form one of the most enigmatic partnerships in the entire solar system. New Horizons revealed a terrain that defies expectations. Jagged cliffs of nitrogen ice, methane ice towers as tall as skyscrapers, cryovolcanoes that may have once spewed water instead of fire, some even taller than Everest, and deep, winding canyons that make the Grand Canyon look like a scratch on the surface. These aren't just features. They're testaments to activity, to change, to something very much alive. How could such a small world be so restless? Look closely at Pluto and you'll see it, etched across the surface like a cosmic signature, a vast, heart-shaped basin known as Sputnik Planitia. But this isn't just a charming coincidence. This icy plain may hold the key to something astonishing. Beneath its frozen surface, scientists suspect, lies an ocean, a subsurface sea of liquid water, insulated by layers of ice and warmed by forces we are only beginning to understand. On a world this cold, that's like discovering fire on the moon. For liquid water to exist under such brutal cold, the conditions must be extraordinary. But Pluto, against all odds, checks every box. Salts dissolved in the water lower its freezing point. High internal pressure keeps it from crystallizing. And most intriguingly, tidal forces, subtle gravitational squeezes from Charon, might generate enough friction to produce heat. Together, These elements create the possibility of an ocean up to 150 kilometers deep. That's more than 10 times the depth of Earth's deepest trench. And where there's water, there could be life. To test the ocean theory, scientists turned their gaze to one of Pluto's strangest regions, a landscape called chaotic terrain. Imagine a geological fever dream: ridges, troughs, and jagged formations twisted into a frozen mess. Researchers simulated how an asteroid impact might create this. Shock waves, they suggest, could have wrapped around Pluto's core and collided on the opposite side, ripping up the surface. But for the pattern to match what we see, Pluto would need that deep underground ocean to amplify the seismic energy. The terrain, it seems, speaks of a liquid heartbeat below. During its flyby, New Horizons only had time to capture one side of Pluto in full light. The far side, cast in eternal dusk, remained in mystery, glimpsed only in lower resolution scans. But even these hinted at vast plains, unexpected colorations, and surface formations we've yet to explain. It's a haunting thought that, on a world so remote, even half of it remains visually unknown to us. A shadowed hemisphere, frozen in secrets, waiting for our return. Among Pluto's many enigmas is its strange reddish hue, especially near the equator. It's not paint, but the fingerprint of complex organic molecules known as tholins, born when sunlight and cosmic rays bombard methane, nitrogen, and water ice. But here's the thrilling part. Some of these molecules are precursors to the very building blocks of life. Under the right conditions, like the presence of ammonia, also detected on Pluto, these chemical reactions can generate the foundations of RNA and DNA. Pluto, it turns out, is not just chemically active, it's chemically promising. If life exists on Pluto, it wouldn't be cities under glass domes or towering alien civilizations. It would be humble, microscopic, simple, hidden in the shadows of an underground sea. Perhaps clinging to hydrothermal vents in the ocean's rocky floor, just like early life may have begun on Earth. And though we haven't found these organisms yet, the signs, liquid water, organic chemistry, and a potentially stable environment, are stacking up. Life may not need warmth or sunlight to flourish. It might just need time, and Pluto has had billions of years to get it right. Before New Horizons, our best view of Pluto came from the Hubble Space Telescope, blurry, pixelated smudges that barely hinted at shape or shadow. Now, with breathtaking detail, we've seen towering ice mountains, cryovolcanoes, and plains that stretch like frozen oceans. And yet, these discoveries have only made the questions louder. Why is Pluto geologically active? Why do its features shift over time, as if the planet is breathing beneath its crust? These are puzzles too vast, too profound to solve from a single flyby. We need to go back. Imagine a mission, not a flyby, but a full-scale orbital expedition. A spacecraft designed to circle Pluto for years, mapping its poles, peering into its craters, scanning the magnetic fields, and perhaps, just maybe, deploying a lander to explore the surface. That's what scientists are dreaming of, because Pluto, far from being a dead relic, is proving to be one of the most compelling candidates for habitability in the solar system. It demands our curiosity. It deserves our return. Pluto's journey mirrors our own, once celebrated, then cast aside, and now rediscovered in a light more glorious than we imagined. It's a reminder that science is not just about classification, but about wonder, about revising what we thought we knew. Pluto didn't shrink. It grew in mystery, in richness, in significance. Like a forgotten story buried in ancient ice, it waited patiently to be heard again. And when we listened, it whispered secrets that shook the pillars of planetary science. What if life doesn't need warmth or sunshine? What if it doesn't bloom in lush jungles or dance in oceans under a golden sky? What if life begins in the silence, beneath a frozen crust in black oceans warmed by ancient tides? Pluto challenges our definition of life, not just biologically, but philosophically. It asks us to open our minds wider, to accept that existence can flourish in places we once considered unthinkable, that the universe is more generous, more creative than we ever dared to believe. Pluto is not the end of the solar system, it's the threshold. Beyond it lies the Kuiper belt, a region teeming with icy worlds and unknown objects. Exploring Pluto is not just about one planet, it's about unlocking a new category of exploration, a place where time slows, chemistry whispers, and the rules are rewritten. In a way, studying Pluto is like peering into the early solar system, preserved in ice, frozen in time, but full of clues to how it all began, and perhaps how it might end. We once thought of Pluto as the loneliest world, but now we see it for what it truly is, a beacon on the edge of the dark, pulsing with secrets, daring us to return. So here's the question that matters now. What else is out there? If a tiny frozen world billions of miles away could harbor oceans, organic chemistry, and the potential for life, what are we waiting for? If this journey into the unknown stirred something in you, an echo of curiosity, a flicker of wonder, then don't let it fade. Subscribe, like, and stay with us as we continue to unravel the mysteries of the cosmos. Because this is just the beginning.